Alright. Here we go. We are in chapter 5. Now, this next test will be your last test for chapters 5 and 6. Okay? So, and I got a new setup in my office. So your last test is over chapters 5 and 6 together. And then we'll be looking at finals. Okay? So we're trying to finish these up. Okay? So some of the stuff we're going to do here today is you're probably not going to have on your homework, but you should know how to be able to set some of these things up, and we want to make sure we are on the same track as everybody. Okay? We'll see if this goes into 2 videos or not. I'm not sure yet. Alright, so we're going to talk about systems of equations. Okay? So, and we're going to just be dealing linear equations today. Okay? For 5.1. And so you guys have done system equations. You did them in Algebra 1, we did them in Algebra 2. Heck, you may even touch them on geometry. So, you know, basically, when we talk about system of equations, we're talking about when we take 2 lines and we try and see where they cross. Okay? So, remember, if they cross something like this, you're going to have one solution. Okay? If they don't cross and they're parallel, you have no solution. And then the third option, remember, is if I have a line here, and then we have another line over top. Okay? They're the same. They end up being the same line. You're going to have an infinite number of solutions. Now, we are going to show how to write that answer. This is going to be something new for you. Okay? So just FYI as we get to something like that. Now, how do we tell if an ordered pair is a solution? Okay? Well, there's a couple ways to do it, but the easiest way is just to plug in both. Okay? And see if you get the same answer here. So if I plug the negative 3 and the 5 in, that's going to be 2 times negative 3 plus 6 times 5. Which is going to be, what, negative 6 plus 30, which is 24. So far, so good. And then plug it into the bottom. You've got to check both. Negative 3 plus 5 times 5, which would be negative 3 plus 25, which is what? 22. Okay? So, in that case, we're going to end up with a no. Okay? So, let's try this one. Okay? So here's your 0, here's your x, and here's your y. So it's going to be 5 times 0 plus 10 times a half. Well, that's 5. Plus 0 is 5. Good. And now 20 times 0 minus 6 times a half. That's going to be 0 minus 3, which is good. Yep, so this is yes. Simple as that. Okay? Now, we talked about a second ago, you have your different types of answers. Okay, you're going to have intersecting lines, which gives you one solution. Parallel lines, which we call inconsistent, which is no solution. And then we have the infinite many solutions, which we call dependent, which one we call those are the same lines. Okay? So, if you remember back in Algebra 1 and Algebra 2, you dealt with these, okay, especially in Algebra 1. Okay, there you had 2 different methods. We had substitution method, and we have the addition method, which some always call this the elimination method. Now, this book calls it addition method because they always use addition, but in elimination method, sometimes you use subtraction. Okay, so we dealt with those. Now, if you look here, we have a problem here. Here's my problem, and here it is graphed. So we already know this here is going to be my solution. Okay, now they're asking us to do this as a substitution method. Okay, best when you have a y or an x by themselves. Okay, now notice here, there's that y, all by itself. So if you solve this for y, 5x minus 26, y is going to be 5x plus 26. And then what we do is we substitute it into the other one. Has to go into the other one. So 2x plus 3 times 5x plus 26 is equal to 10. And we're going to solve for x. Distribute. 2x plus 15x plus 26 times 3, 678 is equal to 10. Alright, so that's going to be a negative 68. This would be a 17x. And 17 is going to add that to negative 4. Which looks like it's at negative 4. Good. Okay, so far so good. Okay. Now we got to plug this back in to one of the two equations. Probably easiest to put it into this one, but the numbers aren't too bad on either one. 5 times negative 4 minus y is equal to negative 26. Be negative 20. Move the 20 over. Negative x is equal to negative 6. Y is equal to 6. So this is up 6. So I get the example, negative 4, 6. And my answer is my point at negative 4, 6. Make sure you write it as a point. And it has one solution. Okay? Alright. So, let's now look at, let's look at here this example, number 4, on our notes. It says now using the elimination method. Okay? So, as I look at this, okay, in addition method or elimination method, like we said, we want to get one of the variables to cancel out. Now notice, same problem as last time, so we already know our answer. But doing the same problem, okay, and let's try and get rid of the y's because they are already opposite signs. So we're going to multiply this by 3, okay, which is going to give me 2x plus 3y is equal to 10. And then we multiply by, that would be 15x minus 3y is equal to, that's what, negative 78, what we had last time. Okay, so now we add. Why do we add? Because these are opposite, they're going to cancel each other out. Which gives me 17x is equal to negative 68, which is x is negative 4. And we plug it back in, and we get negative 4, 6 again. Okay? Alright, so we know both methods. Okay, so if you look at number 5 here, notice there's nothing, well, this is kind of by itself, and you can do a couple different things with this, but, okay, decimals, since you technically don't get a calculator, we would have taught this as, let's get rid of all your decimals. Okay, so the way I would get rid of decimals first is multiply this one by 10, and this one by 100. Now, why would I pick 100? Is so that that 0.28 becomes 28, which would give me 50x plus 3y is equal to 14, and then the bottom is going to be 20x minus 10y is equal to 28. Right? Now we want to determine, so that's going to move this over 2 spots, right? 2 spots, 2 spots. Okay, so now I got to do something. Okay, what am I going to use? Well, best to use elimination or addition method here. So if we multiply this top one by 10 and this bottom one by 3, we're going to get 500x plus 30y is equal to 140. This is going to be 60x minus 30y is equal to 28 times 3, 24, 6, 84. And we're going to add. Okay, so we're going to add this. Okay, And so we're going to get 560x is equal to 224. Okay. Alright, so we're going to get x is going to be 224 over 560, which will reduce to 2/5. Okay, so if you don't know how to get to the 2/5, then you can work it later. Okay, but now I got to find the y, and I want to plug it in. I can either plug it in here, 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 or here. Okay, in essence, that 2/5, if I'm going to plug it in for x, plug it into this one. Be 5 times 2/5 plus 0.3 y is equal to 1.4. So that's going to give me 2 plus 0.3 y is equal to 1.4. Okay, which means then I'm going to subtract the 2. And if you want, you can multiply everything here by 10 again, which would be 20 plus 3y is equal to 14. This will be 3y is equal to negative 6, and y is negative 2, which gives me the point 2/5, negative 2. Booyah. Okay, so not too shabby, if I do say so myself. Okay, alright. So let's look at this next one. Okay, this next one, notice I have a fraction, and here's basically what you can do is, because this is here, why not use substitution? Plug this into here. Okay, which will give you 2x plus 4 times 5x minus 7/4. Now, why do I know I can do that and not have to worry too much? Well, I looked real quick. That 4 times the 1, that fourth is going to cancel each other out. So when I distribute this, we're going to get 20x minus 7 is equal to 4. Okay, which means this is going to be 22x is equal to 11. X is 11 over 22, which is 1/2. Okay, and then I need to plug it back in. Now, where would be the best place to plug this back in? I'm going to be smart about it, because that 1/2 I know is going to cancel out with that. 2 times 1/2 plus 4y is equal to 4, because that's going to give me a 1 plus 4y is equal to 4. Always look ahead. Okay, this is going to be 4y is equal to 3, or y is 3/4, and so without a calculator, I got 1/2 and 3/4, like so. Okay, so again, if you look ahead, things will help you out. Okay, alright, so going to 7. Okay, so as we look at 7, we got some work we got to do. Okay, so we're going to look at this. We're going to distribute just to see what we get. 3x minus 3 plus 10 is equal to negative y. This is going to be 6y minus 30 is equal to 4x minus 28. So I got a lot of stuff here, so let's kind of put some things together. Let's put them in the order we want them in standard form. 3x plus y is equal to, this is going to be 7, so it'll be negative 7. Okay, and we're going to have 4x minus 6y. Okay, because that's going to go over here, and then this negative 28 is going to go over here to make it equal to negative 2. Okay, so what do I use? And then substitution, elimination, both of them are going to work pretty well. Okay, I'm going to go ahead and do elimination, so I'm going to multiply this by 6, which gives me 18x plus 6y is equal to negative 42. This is 4x minus 6y is equal to negative 2. I'm going to get 22x is equal to negative 44, which is x is negative 2. time to plug it back in. I'm probably looking at one of these guys. Why not this guy here? Looks simple. 3 times negative 2 plus y is equal to negative 6. That's a negative 6. We'll bring that over as a 6. Y is going to be negative 1. My point's at negative 2, negative 1. Done. All of these have one solution. Okay? So, let's now look at what happens when there's not one solution. Okay? So, if we look at this problem, we don't know anything about this yet. Okay? And so as we look at it, it looks, hey, I think I can do substitution with this because y is equal to, so why not do substitution? Put this in for y. So I get 10x minus 5 times 2x minus 6 is equal to 30. Now I'm going to distribute. 10x minus 10x plus 30 is equal to 30. Those cancel each other out. I get 30 is equal to 30. Whenever this happens, okay, this is one of those infinite solution problems. Okay, but now in college we write this a little bit differently than saying infinite number of solutions. Okay, so how do we write this? Well, the way we're going to do this is we're going to put it in set notation. Okay, and the way it's going to get written is as follows. We're going to take this means infinite number of solutions, which means for whatever x value I get where I plug in, we're going to get the same y value every time, which means we're going to get this right here. Okay, we're going to take whatever this line is always going to be 2x minus 6. This is the line we're going to use. It's the same line. So the y value in terms of x is this. Okay, the mx plus b piece. So we're going to say the point is going to be x comma 2x minus 6 such that x is any real number. Okay, so this is what we have to write right here. Okay, whenever you get infinite number solutions, it's going to be x comma mx plus b, which is that line, such that x is any real number. Okay, simple as that. Alright, so let's look at this last one, number 9, and then we're going to call it this video. Okay, so a couple things. Ooh, fractions, yeah, fractions. Let's get rid of fractions first and foremost. Let's multiply by common denominator. 3x plus 5y is equal to 1. Multiply this by 2. 3x plus 5y is equal to 4. Okay. Now, if I did this as an elimination, notice what happened. I just have to subtract these. That's what I would do, subtract them. Those cancel, I get 0 is equal to negative 3, which is not possible. Okay? Which means this is no solution. If we write no solution, we can write the empty set for that. Okay, all this means is does not cross. Okay, this would also, we also talked about the terminology on the front page. This is inconsistent. Okay, well, infinite solutions are always dependent. Okay, so if they ask you which type, you got independent and inconsistent. Alright, so that is the algebra piece of this. Part 2 in a minute, when I get started on part 2, is going to be the word problems part of it. Alright, so I hope this helps.